Hello everyone, welcome to my U programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is amount of time for binary tree to be infected. Okay, now let's begin with the problem statement. So you are given the root of a binary tree with unique values, and an integer is given to you. Start at 0th minute. Infection starts from this particular node with value start. Each minute node becomes infected if it is currently uninfected. Okay, infection is not spreaded in that node, and the node is adjacent to an infected node. So if we take this particular tree as our example, let's say, uh, so if let's say the starting node is 3, this is the start node. Then uh, at the 0th time, it will be infected first. Okay, uh, or say 0th unit of time. Okay, then it is said that whatever will be the neighbors of this node, and if those neighbors are not infected yet, then they will be infected. So what are the neighbors? 1 is the neighbor, 10 is the neighbor, and 6 is the neighbor of this node. So infection will be spreading like this. They are immediate neighbors. So at 1th unit of time, these ones will be infected. Okay, so these ones will be infected at 1th unit of time, and then infection will keep spreading in this manner, and soon the whole tree will be infected. Okay, so uh, the given tree is a binary tree. It is a kind of a graph which is connected and there are no cycles. So 3 is very well connected with 10 and 9 because 10 is the left child of 3, and 6 is the right child of 3. So these connections exist. Which connections I am talking about? These connections. So they are something like this. They are unidirectional. They are going from 3 to its children, not from children to 3. And another thing, that another type of connection that we will be requiring is the connection of, just a second, connection of node with its parent. Okay, so there is no such connection, so we have to build that. So for each node, what connections are required? Three connections are required. First is to its left child, Second one, if it exists, condition applied. Second one will be its right child, and third one will be its parent. And these connections should be bidirectional. Okay, so that we can easily go in either of the direction. From, let's say, parent to child, the connection is there and already there, but we will be forming a graph kind of structure, and in that connection every connection will be bidirectional, so it will be taken care of automatically. Okay, so let's say uh, 3 1 is 3 is child of 1, so there will be connection something like this. From 1 to 3 there will be this bidirectional edge. Okay, you can go either in this direction or in this direction, it's up to you. So every connection in the graph that we will be forming with this given tree will be bidirectional edge. So every edge should be bidirectional. We would have easily worked with this particular tree, but since we are not provided with the bidirectional edges in the tree, so we will be making a separate graph out of this tree, and then we will be applying this breadth first search of breadth first search kind of approach. As you can see, first the neighbors of a node are visited, then uh, their neighbors, and then their neighbors. Similarly, the infection keeps on spreading. Okay, so it is spreading in a breadth first search kind of manner. Okay, BFS manner, it's spreading. Okay, so you can consider it level 1 or level 2, you can say it, and this can be considered as level 1. Similarly, the time that it will take the infection to spread completely in the entire tree will be number of levels. Number of levels. Okay, each level will be taking each level will be adding 1 unit of time. So the first level will be adding 1 unit of time, then the time will be 1, and then for the second level the time will be 2. Similarly it will go on, and that's how the infection will spread. So level by level, visiting neighbors first with each uh, time unit, let's say, passed. So this is the whole approach. Let me summarize. First of all, we will be making a graph with bidirectional edges. For each node, 3 edges will be there. This type of edges: left child, right child, and its parent. Bidirectional edges will be there. Then what you will do? You will simply apply BFS, or say level order traversal. And time required to completely the tree to get completely infected will be number of levels. Time required to tree to get completely infected. Okay, So this is how we will be solving this particular problem. And now let's have a look at the implementation of this particular problem. Also for the time complexity part and space complexity part, I will be explaining it at the end. uh, those of you who are new to this BFS and you can say level order traversal, I will be providing links of the articles explaining these concepts, level order traversal and BFS. Basically it is the kind of level order traversal is kind of BFS only. So you can explore those articles and then you will be able to understand in a clear way why we are using BFS here. So links will be provided for these. Now let's move towards the implementation. Also, you have to find out your infected node while making the graph. In this step, we will be finding your infected node. Since only the infected node's value is given to you, its address is not given to you. So we will be taking care of that also while building the graph. So let's begin. So this is the variable that will be returned at the end. Okay, and this is the data structure that will be used for level order traversal. Okay, or say BFS. And this is the data structure that will be used to make bidirectional edges for each node. This is the data structure that will be used to make bidirectional edges for each node. Okay, one for its left child, one for its right child, and one for its parent. One for left child, one for right child, and one for its parent. Okay, so for each node, these three edges will be made subjected to the availability of right child and left child. Every node except the root node will be having a parent. So that's the case, and this function is used to build the graph. It is a depth first search kind of approach to build the graph, DFS. Those of you who are new to this concept also, this traversal technique of graph, or let's say searching technique of graph, I will be providing link for this one also. Okay, and then let's see how is this build graph function is implemented. This is just a standard DFS. Okay, if the root value is null currently, then you will be simply returning from that. And if that's not the case and your root is having a left child and a right child, then you will be making bidirectional edges. Make bidirectional edges. In case the current node is not null and is having children. Okay, and also recurse for the subtrees of those children. Okay, so that's the case. uh, Similarly for the right child also, it will be the same thing, making bidirectional edges. One edge is going from, you can say, see here, root to its left child, and then one edge is going from its left child to root, so it's a bidirectional edge. Okay, that is how we will be making connections and in the graph. Now once we are having the graph also, there is this line that will be finding your start node index as per the given value of start in this input. Okay, so this value will be found out. I have initialized a global variable here, so start node's value will be having the node from which the infection will be beginning at the 0th time. Okay, so you can I should write comments here. This is the node from where the infection, or you can say this is the first infected node. At time 0. Okay, then we will be simply doing a level order traversal. This is just a standard implementation of a level order traversal, nothing fancy here. So level order traversal implementation. Okay, and then you will be simply returning the time that is passed -1, because it will be incremented more than once more than required. Okay, as we are doing post incrementation here, so that's the case here. And for the level order traversal, you should be visiting this link. Okay, here level order traversal is explained pretty well. I will be providing this link. So that's how we will be solving this particular problem. If you are still having any doubts or any queries in general, please feel free to ask them in the comment section. Thank you for watching. Have a great day ahead.